Today's the 3rd. It's going to be Thanksgiving before you know it. This will probably be the last lecture, like notes that you actually have to take before we're done with word problems. Because there'll be assignment 18 today, and there'll be an assignment 19 and probably like a practice quiz next week, but they won't have like new things. So this is the end of the new stuff here today. So that's good. If you're all caught up, you feel good about that. So these are more age change problems. So I'm just going to call like more age change problems. And the difference today is that we're not going to be looking for ages sometimes. We're going to be looking for how long does it take for something to be true. So rather than every problem saying like 5 years from now, blah, 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 it'll say like, in how many years will this be true? So our variable isn't going to be an age, it's going to be an amount of time. And that'll make more sense once you see the first one. So I say there's just 2 of these. So your first one, it'll throw you for a loop right away. Mark is 26 and his father is 58. So right out of the gate, you're like, what gives here? Like, I would like giving me the answers, but again, those aren't going to be the answers, obviously. So the question is, in how many years will Mark's father be twice as old as Mark? This shouldn't take long. By Mr. Ahern standards, that probably means like 15 minutes, but I'll try to keep it as short as I can. So again, we don't seek an age, we seek an amount of time. We're trying to figure out, is it 5 years from now, 12 years from now? Yeah. I did one of these while I was driving with my son the other day. I was trying to figure out how long is it going to take. He's 17 and I'm 49, and we were trying to figure out when will I be a third or 3 times as old as him. So we were driving down the road. He probably didn't want to do it, but we did an algebra problem while driving. No paper or anything. I wouldn't be safe. Mental math. You know what I mean? Okay, good. Let's do this. So what is our x going to be? Nope. Say it again. Yes, let x equal the number of years. So again, we are not seeking an age today. The age is already done. Like I literally told you how old Mark is. He's 26 and his dad's 58. So the question isn't how old is anybody? We know that. The question is how many years from now will his dad be twice as old as him? So clearly right now, his dad's not twice as old as him. If you did twice Mark's age, twice 26 is of course 52. And his dad's like, well, he's not 52, he's 58. So there's going to come a point at some point in the future where Mark can say to his dad, hey, dad, you're exactly 3 times as old as I am. And our mission is to figure out when is that? And that's what x is going to be. So x is going to be the number of years. And honestly, that's the only variable that you need. You don't need anything more than that. So just a single variable declaration for these problems, nothing to it. So any thoughts on this? Like I could just show you what to do, but do you have any thoughts on how we could write an equation? Let me ask you this. Maybe let's make a variable. Let's make some more variables and see if this helps you. Let's call this future Mark. We'll say future Mark's age. How's that? And then let's do another variable for future dad's age. I don't know if that's weird English or whatever, but it is early, so we can all be forgiven. So future dad, we'll call him future Mark. So like in 5 years, he's going to be future Levi, you know what I mean? So we have a future Mark's age and future dad's age. This might help you to go this route. I don't know if these are necessary, but I think they'll help us. So how old will Mark be in the future? Nope. Nope. What's that? We don't know yet, but we can, as you know, in algebra, we can still represent things that we don't know. So how old will Mark be in 1 year? How old will he be in 2 years? How old will he be in 5 years? 31. How old will he be in 10 years? 36. How old will he be in 15 years? 41. All right. How old will he be in X years? Not 26X. That doesn't make sense. That would be saying that in 10 years, he'll be 260 years old. He'll be this old. Very good. He'll be exactly 26 plus X. And the idea is we don't know what X is. That's what we're trying to figure out. X years from now, and Zane said it, we don't know. That's the answer to a lot of questions. And before you take algebra class, you're just kind of like hosed. You go, I don't know. But in algebra, if I don't know something, I can still define it and write it down using a variable. So in X years, I don't know what X is. Mark's going to be 26 plus X. If it's 6 years from now, he's 26 plus 6. How old will Mark's dad be in the future? Good. So future dad is 58 plus X. And again, we don't know what X is, but there is some magic point in the future where Mark is going to be exactly half as old as his dad. Or conversely, his dad's going to be twice as old as him. So having said that, can you write me an equation? I'll write it in words while you ponder that. How's that? Here's what I want. I want this, and you do too. We all want future dad, his age, to equal exactly twice future Mark. Yeah, and I don't want you just to write that down and take it on faith because I'm your math teacher. Like that should make sense to you that that's what we want. At some point in the future, if I double future Mark's age, it should equal future dad. You buy it. And again, we would not put the 2 with the future dad. That would be silly. You saw me do that yesterday. That's why would I do that? I want to double dad's age. There's no way Mark's ever going to catch up if I double dad. So there's the situation written in white. And now I have everything I need. What am I going to put in place of where it says future dad? I'm going to say 58 plus X. I want you to be the same as double what? Yes, and there it is right there. There's my algebra. And again, going back to Zane, I don't know. That's the whole point. I don't know what X is. But using algebra as a tool, I can find it. The math gods aren't going to lie to me about this. Like it is. Math is not negotiable. So there's steps 1 and 2. Always the hard part. And then step 3 is solve it, right? Easy McSneezy. So we got to distribute, of course, and we get, what's 2 times 26 again? So we get 52 plus what? 2x. And you should, again, here in November, be getting to the point where you can actually just see an equation solve itself right before your eyes. We don't probably see them this way in August or even maybe in September, but at this point, you should literally see that single X flying across to the right and taking away himself, like 1X away from the 2X and leaving us with 1X. And then on the flip side of that, you should see the 52 flying across as a minus 52, taking himself away from the 58. And what do we get? We do get X equals 6. So we claim that in 6 years' time from now, Mark will be exactly half as old as his dad. What's nice about any problem like this is you can vet it. You can make sure. Let's make a check before we state our answer in yellow. Like before I write my answer, I want to know if this is legit. Like, is this a bunch of hocus pocus? In 6 years. So I'm going to write up here, like in yellow, up above. How old So I'm going to put a box around Mark's age. Right now, he's 26. How old will he be in 6 years? He'll be 32. Let's just check it and make sure. Again, I want to know if this is legit, this black magic I'm doing here. And Mark's dad is currently 58. How old will he be in 6 years? And then you can see it for yourself, like, I'll be darned. Look at that. In 6 years, Mark's dad is 64. Mark is 32. Proof positive. 64, of course, you're in high school. You can tell that 64 is twice as big as 32. So you could say something like, it will happen. I mean, there's other, it's, what is this, 8:05 on a Thursday morning. Maybe my English isn't the best. You could come up with maybe better ways to say this, but it will happen in 6 years. And the use of that pronoun it, Mr. Mercer would probably have words to say about that, but you get the idea. If you wanted to make a better sentence, you could say something like, in 6 years, Mark's dad will be twice as old. You know, he'd be, the English teachers, all of them would be much more proud of that. It's always English, bro. Walking on American soil, you're always in English class. I believe that firmly. So, any questions about that? As you might guess, we're going to do another example. In this example, would you like to guess what's going to be different? See, can you predict? Because if that was it, I would honestly do one example. We're going to go in the past tense. Very good. So now we're going to go back in time for example 2 and ask ourselves, going back into the past, at what point in time was a certain thing true? That's the goal. Okay. So let's do another one. And that'll be it. We're going to say that Rita is 48 and her daughter is 26. Quick. How old was Rita when she had her baby? 22. Good. So Rita's 48. Her daughter is 26, period. How many years ago was Rita 3 times as old as her daughter? I said this weeks ago. The very first day I remember when we started word problems. Could a motivated 5th grader answer this question? Yes, and they wouldn't have to know anything about X's and 4-step processes and all this about distribution. A dedicated 5th grader would just start playing around. But we're not dedicated 5th graders. We're algebra learners. We're teaching our brain how to solve problems using non-guessworky structural processes. But a motivated 5th grader would just go, oh, let me try 2 years ago. Let me try 3 years ago. And eventually they'd be like, oh, jackpot, I found it. But that's not what we do. Not around here. So again, what's X going to be? The number of years. Yet again, we know all the ages. We know that Rita's 48. We know her daughter's 26. We're trying to find an amount of time that we have to go back for a certain thing to be true. Going forward, Rita will never again be 3 times as old as her daughter. Ever. It's impossible. But there was a point in the past. So let X equal the number of years. And let's define those past tense variables. So like last time I said, you theoretically could stop here, but I think it's pretty smart to go back in time. So again, how old was Rita 3 years ago? 45, right? How old was Rita 10 years ago? 38. How old was Rita 6 years ago? How old was Rita X years ago? 48 minus X, right? That's the idea. And going back again to Zane for the 4th time, not to pick on Zane, but if I said, how old was Rita X years ago? You say, I don't know. And I agree with you, but we can write it down still. We can say, let 48 minus X equal Rita's, we'll call it her past age. How's that? That's a little bit more professional than the way I did the last one. I like that better. How old was Rita's daughter in the past? Again, 26 minus x. And we have to continue using x because the same amount of time has to transpire for Rita and her daughter. Yeah, we can't cheat this and have daughter go back in time 10 years and Rita stay 48. I mean, oh, they did it 48 and 16. So they're both going back the same amount of time until the magic happens. So 26 minus x, we'll say, is daughter's past age. So again, the situation that we're striving for is we need, we'll call this Rita in the past. We want to equal 3 times daughter in the past. It's important that you buy into that equation, that you agree with the situation, and that you don't do what your teacher did yesterday and put the 3 on the wrong side. We don't want to triple Rita's age. We want to triple the daughter's age to equal Rita's. That would make more sense, of course. If you don't use the words, it's okay. Like, you don't have to, but if you find yourself struggling, this thing that I've written up here in white in my handwriting, it will help you. It really will. So I'm not going to tell you you have to. It's a good idea. So how old was Rita in the past? What can I put in place of Rita in the past? I can say 48 minus x is equal to 3 times something. And how old was Rita's daughter in the past? Right. And so this algebra equation is going to eliminate any guesswork. It's going to keep me from having to wonder, was it 3, 4, 5? I don't know how many years ago. But x will tell us. It's what algebra does. So let's solve. No work to do on the left. It's just 48 minus x. What do we get on the right? 78 minus 3x. Very good. And again, the process of solving an equation, it being November, can happen for you if you want it to. If you're not ready, show your work. But I personally am of the opinion that I can just take that minus 3x and I can see him moving over, becoming a plus 3x. And when he combines himself with the minus x, what do we get? We get positive 2x. And again, it's a little dangerous still for some of us in this room. We wonder, like, how did you get that? And how I got it is I am adding 3x. This is what I would have demanded of you back in August and part of September, right? So if that's what you want to do, you do it. You show it. You're adding 3x, which creates now over here a positive 2x. But then if the x's have taken over the west side, then the 48 is no longer welcome on the west side, and we must subtract 48 from this side and from this side, giving us 30. Show it, don't show it, just don't miss it. We should be past the point now where we're making mistakes on the algebra itself. So what's x? Let's check this and see if this is a bunch of hullabaloo. So we make the claim that 15 years ago, if we could go back in time 15 years, that Rita and her daughter would have that cool age relationship. So let's go up here to Rita. She's currently 48. How old was she 15 years ago? She was 33. Her daughter is currently 26. How old was she 15 years ago? I'll be darned. And look at that. We can see it with our own eyes that Rita's mom 15 years ago was, in fact, exactly 3 times her daughter. 3 times 11 makes 33. Any questions about that? So phrase a sentence however you want. Make it decent, proper. You could just do blah, 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 15 years ago. Blah, 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 15 years ago. right? And I clearly ran out of motivation when I just decided to put a bunch of dots. So that's not maybe setting the best idea. Do you have any questions? So again, today we do not hunt for ages. We hunt for an amount of time that it takes for something to be true. Our X in these problems will not be an age. They will be an amount of time. Okay. All right. That is not true, by the way. I want to say this before I stop the recording. That is not true for every problem on assignment 18. These are mixed in now with some other age change problems, more from yesterday's sort of lesson. So don't think that every time today X is going to be a number of years. I will know X is a number of years when it says like how many years from now or how many years ago. Otherwise, it'll be like what you're used to. Righto.